Did you know that in a typical office building, over 10,000 wireless data transmissions happen every single second? That's like trying to coordinate rush hour traffic in every major city simultaneously. And today on Technically You, we're diving into the revolutionary technology making it all possible.
That's such a mind-blowing number. And until recently, all those transmissions had to basically wait in line, right?
Exactly right. Think of old Wi Fi like a busy coffee shop with just one barista trying to serve hundreds of customers. But now, with MU-MIMO and OFDMA, it's like having a team of baristas who can handle multiple orders simultaneously.
Hmm. So how exactly does this magic happen? Because I'm guessing it's more complicated than just adding more baristas.
Oh, it's fascinating. MU-MIMO, multi-user, multiple input. Multiple output uses something called beamforming to create invisible data highways in the air. Imagine having 8 separate spotlights that can track and deliver data to different devices simultaneously.
Well, that's quite different from the old days when Wi-Fi was basically shouting information in all directions and hoping devices would catch it.
You know what's really cool? Starting with Wi-Fi 6, these beams work in both directions. So not only can your router send data to multiple devices, but multiple devices can send data back simultaneously. It's like having a conversation where everyone can speak at once, but somehow nobody talks over each other.
Though I'm guessing there must be some catches to this seemingly perfect system.
Well, here's the thing. Your devices need to be equipped with the right technology to take advantage of it. It's like having a super advanced TV remote that only works with newer TVs. And that's where OFDMA comes in to help.
So what makes OFDMA different from MU-MIMO? They sound like they're solving similar problems.
Think of OFDMA like a smart highway system. Instead of having fixed width lanes, it can instantly adjust lane sizes based on what each vehicle, or in this case, data packet, needs. A smart doorbell notification doesn't need the same bandwidth as a 4K video stream.
That's incredibly efficient. How much of an improvement are we talking about in real-world scenarios?
The numbers are actually staggering. In dense environments like stadiums or conference centers, these technologies can handle up to 4 times more simultaneous connections than previous Wi Fi generations. And get this, they can reduce latency by up to 75%.
Those improvements must be making a huge difference in emerging technologies like virtual reality and augmented reality.
Oh, you're absolutely right. And here's what's really exciting. These technologies are actually helping extend battery life on our devices. Because they're not waiting in line to transmit data, devices can complete their communications faster and go back to sleep mode.
Looking ahead, what do you see as the most game-changing applications of these technologies?
Well, I'm particularly excited about how this enables smart cities. We're talking about environments where thousands of sensors and devices need to communicate constantly. Traffic lights, environmental monitors, security systems, all working together seamlessly.
That's quite a leap from just trying to get better Netflix streaming.
You know what's really interesting? The technology that makes your Netflix stream smoother is the same technology that could help autonomous vehicles communicate with smart infrastructure. It's all about managing massive amounts of simultaneous data transmission with near zero latency.
Speaking of the future, Wi-Fi 7, the seventh generation of Wi-Fi, brings major improvements over Wi-Fi 6 and 6E and can offer speeds up to 4 times faster. It also includes clever advances to reduce latency, increase capacity, and boost stability and efficiency.
Oh, yes. Wi Fi 7 introduced something called multi link operation, which is like having multiple highways that can be used simultaneously. And it's adding AI driven optimization that can predict and adjust to network demands in real time.
That sounds incredibly complex to implement. What should network administrators be thinking about?
The key is proper RF planning and understanding your specific use case. It's not just about having the latest hardware. You need to think about signal quality, channel allocation, and potential sources of interference. It's like conducting an orchestra where every instrument needs to be perfectly tuned.
So what's the bottom line for someone trying to understand why these technologies matter?
Here's what it comes down to. We're not just making Wi Fi faster, we're making it smarter. Whether you're in a smart home with dozens of connected devices, a hospital with critical medical equipment, or a warehouse with automated systems, these technologies are creating the foundation for our increasingly connected future. And that's something worth getting excited about.
So in closing, if you're designing wireless networks for high-density, high-performance environments, understanding MU-MIMO and OFDMA is critical.
Thanks for joining us on Technically You. Subscribe and share with your fellow engineers or tech enthusiasts. And stay tuned for our next deep dive into the tech transforming tomorrow's networks. And as always, stay curious.